uniform circular motion. So the circle that our object is traversing is parallel to the ground. The object we have is a jet airplane or an aircraft, as described in this left image here. The circle it's traversing has radius r, and there is a force that keeps our jet aircraft in the circle, and also that keeps it aloft. That would be due to the lift force that acts on the wings of the aircraft. We know the speed of the aircraft. It's 123 meters per second. That's the speed of our aircraft that's traveling in this circle. In other words, the magnitude of the velocity. We also know the radius of the circle as it banks. That's 3,800 kilograms. The question is, of this lift force that keeps our aircraft aloft or from falling, and also brings the aircraft or allows the aircraft to travel in the circle. Because we're traveling in a circle, there must be some centripetal force that's causing our object, in this case our aircraft, to travel in a circle. But that force, the lift force that's contributing partly to that centripetal force, is also supplying a certain amount of lift to oppose the gravitational force that's trying to pull down on the object. We're trying to find what is the magnitude of that lift force, and then also what is the angle of bank associated with this aircraft if it's traveling toward west of north, some degrees west of north, lift force, the number of degrees west of north that lift force is oriented would be our bank angle, theta. All right, a few things we can analyze here is that we can split this lift force into two components. One component that is opposing the weight, and another component that is contributing to the centripetal force. Here is the centripetal force, which is a component of the lift vector. Here is the component of the lift in the y dimension that is opposing the weight. Y's acceleration must be 0 because our acceleration in the y dimension is 0. The force in the y dimension, or a y component of the lift force, is pointed upwards or positive. So the magnitude of the lift, positive. The weight is in the opposite direction, so we'll say minus the magnitude of the weight. We force, and then our centripetal acceleration is v squared over r. So our centripetal force, our lift in the x dimension, that's the force that's keeping our aircraft in this circle. What the I would be. So if I redraw this triangle that we have over here, just down below, I would find that we have found the lift in the y dimension, or the centripetal component. Adding those two together gives us the lift vector as a whole. And here, angle. We've found lift in x, that's mv squared over r. We've found lift in y, that's the weight, or mass of the aircraft times gravity. Together we can find the lift by relating them to each other using the Pythagorean theorem if we want to find the magnitude of the lift. We know that this is the hypotenuse of our vector triangle here. That if we take the square of the lift, magnitude of the lift in x, or the centripetal lift, plus the square of the lift in y, that should equal the square of our lift, or a resultant of these two vectors. So we need to take the square root of these two which is mass of the aircraft times gravitational field, that quantity squared, that's lift in y. We have lift in x, lift in y, based upon our analysis in the centripetal dimension. Here's our analysis in the y dimension. Square root of that quantity, of that sum, gives us again our magnitude. our in the directions. It is down. It's not accelerating in the y dimension. It's not rising or falling. So those two forces must be equal to each other. Lift in y is the same as the weight. And that makes sense because there has to be a force in the y dimension that's opposing weight to keep it to get that -6. For the bank angle, we look back at our vector triangle here. We're trying to find this angle, how much to the west, or rather, how much west from north, right? The lift in y vector, or the y component of lift, is pointing directly north or upwards. The lift is around a circle in a circular motion that's 1,810 it has this mass, the 10 to the 6 newtons, and while that lift force is generated, the wings must bank 22 degrees west of north.